Hi and welcome to another tutorial video. In this tutorial video what I'm going to be doing is introducing something called a tree. And before you watch this video, what I advise you to do is make sure that you understand what a graph is, because what a tree is it's a particular type of graph. So it's really important that you understand what a graph is, because that will be very beneficial in helping you to understand what a tree is. So what is a tree? Well, a tree is a connected, undirected graph with no cycles. Okay, so if you're asked in an exam to explain what a tree is, that is the key idea to get across. A tree is a connected, undirected graph with no cycles. So let's pick apart this definition and make it a bit easier and clearer to understand. So first of all, here we've got the word connected. So a tree is a connected graph, and what that means is that it's always possible to find a path from one node to another. Okay, so we've got that a tree is a connected graph. We've also got this word here, it's undirected. So that means that all the arcs or the edges in the graph are bidirectional. Okay, so all the arcs and or edges are bidirectional, meaning that you can pass along the arcs or edges in both directions. And finally then we've got that it's a graph with no cycles. So it's got no cycles, and what that means is that you can't find a path in the graph which allows you to return to the same node you set off from without backtracking along a particular arc or edge. Okay, so we've got no cycles in a tree, so you can't find a path that allows you to return to the node that you started at without backtracking along a particular arc. So let's take a look at some examples then of what is and isn't a tree. So this graph here is most certainly not a tree, and the reason that this graph isn't a tree is that if we take the node A as an example, we can find a path, in this case along this arc, along this arc, along this arc, and along this arc, which will allow us to return to A without backtracking along any of the arcs. So that therefore it contains a cycle, and as we saw in our definition a moment ago, a tree cannot contain any cycles. But if we take out an arc between B and D, this graph will become a tree because it doesn't contain a cycle anymore. If, say, I started from the node B, I can't find a path which will allow me to return to B without backtracking along a arc. So if I say try to go along this arc, then this arc, and try to find a route back to B, I'd have to backtrack along these two arcs. So therefore this graph is now considered to be a tree. There is a particular kind of tree called a rooted tree. And what a rooted tree is a tree where one node has been designated as the root of the tree, and the branches of a rooted tree are the arcs, and the leaves are the nodes which have no child nodes. And rooted trees have many applications in computer science, and one of these is to store and manipulate hierarchical data such as folder structures. So this is an example of a rooted tree, and the data that this is storing here is folders, and so we've got the sort of home folder on this computer for a user called Hemingway, and Hemingway has got a folder in his home folder called Documents, also Pictures and Downloads, and then in his downloads he's got a folder for Chrome downloads and a folder for Firefox downloads. In his Pictures he's got a folder for cat pictures. And in this example of a rooted tree, we've got this node here, which is the root, And these arcs here are called the branches of the rooted tree. These nodes here are all the nodes apart from the root are child nodes, and all of the nodes which have child nodes are also parent nodes of those child nodes. So for example, the pictures node is a parent of the cats node, but the pictures node is also a child of the Hemingway node. Whereas with the documents node, it is only a child because it doesn't have any nodes coming off it itself, so it's not a parent node. And these nodes, which don't, like docs, which don't have any child nodes, are called leaf nodes. So you might see that terminology being used as well. A leaf node is a node which doesn't have any child nodes. And you might also see one final term called a subtree. And a subtree consists of a node in a tree and all the children of that node. So a subtree of this tree might be, for example, the downloads node along with the Chrome node and the Firefox node. This is a subtree of our original tree up there. Okay, so that's just a brief introduction to trees and rooted trees. I hope you found this video tutorial useful, and thanks for watching.